differentiating the sets of numbers. This example comes from the OpenStax College Algebra textbook. The instructions here are to classify each number as being a natural number, n, a whole number, w, an integer, I, a rational number, q, or an irrational number, q prime. We'll start with this visual that shows natural numbers, n, as the smallest set of numbers, 1, 2, 3, and so on. When you add 0, you have whole numbers, w. Adding the negatives of those numbers to our set gives us integers. Notice that at this point we don't have fractions or decimals, but when we get to rational numbers, q, we have all of the numbers inside of that set plus fractions. And if we're looking at decimals, those fractions can be written as either terminating or repeating decimals. And then outside of all of those rational numbers are the irrational numbers q prime, things like pi or the square root of 2 that cannot be written as a fraction or terminating or repeating decimal. So for question A, we're given the square root of 36, and before we classify this, we should see if it will simplify, and we can evaluate the square root of 36 as just 6. 6 is a natural number, n. All of the natural numbers are also whole numbers, so 6 is a whole number. All of the whole numbers are integers, so it's also I. And then lastly, since we can write 6 as 6 over 1, it is also a rational number q. So 6 falls into each of these classifications. In our next example, 8/3, 8/3 is not a natural number. It's not a counting number. It's also not a whole number or an integer. However, since it is written as a fraction with a numerator and a denominator, it is still a rational number. So we can classify that with a q. For example, C, we have the square root of 76, and unlike the previous square root that simplified to just a whole number, the square root of 73 does not simplify, so I can't write it as a natural number or a whole number or an integer, and I can't even write it as a fraction. As a decimal, this would go on forever without repeating. So this is an irrational number that we indicate with a q prime. For D, our number is -6. -6 is not a natural number since those are all positive. It's not a whole number, which are also all positive, but it is an integer, I, and we can write it as a fraction, so it's also a rational number q. So -6 is just an integer and rational. Lastly, we have this decimal, which goes on forever. As a decimal, it's not a natural number, it's not a whole number, or an integer. To be rational, it would have to be either a repeating or a terminating decimal. This example does not have a series of numbers that continues to repeat, so it's not rational, leaving us with just irrational q prime.